All right, so our goal today for 3.3 day 2 notes, proving lines parallel, we're going to prove that lines are parallel or that angles are either congruent or supplementary, depending on which angles we are talking about. So the first theorem that we are given is that the alternate interior angles theorem. We learned this the other day. It says if two parallel lines are cut by a transversal, then the alternate interior angles will have the same measure. Okay, so for example, in this diagram here, some alternate interior angles could be 3 and 5, or it could be 4 and 6. So when we go to prove this, now again, you will not have to do proofs on your own yet, okay? I might ask you to explain your thinking, but I wouldn't ask you to come up with an entire proof on your own, okay? So these proofs that we're doing together is for you to understand, kind of get an idea of what a proof will look like eventually when you do it on your own, but you will not be asked to do these proofs on your own, okay? So we're given that these two lines are parallel. That's what these angles or these arrows right here show, is that these lines are parallel. We're trying to prove that the then part of our statement, that alternate interior angles have the same measure. So they said 3 and 5 have the same measure because those are alternate interior angles. We could have also said 4 and 6 have the same measure. It doesn't matter. Okay? Remember, theorems have to be proven, but postulates are assumed to be true. So when we go to do this, we are allowed to use postulates, we're allowed to use definitions. So I did a word bank up here because these are the types of things that we can use for our reasons. The first line is always going to be our given. Sometimes people will choose to state, if there's two givens, they'll state the first one and then they'll kind of wait till they need that second one to state it. So sometimes you'll see that. But for the most part, anything that's given, we write on that very first line, and our reason is always going to be given. Now, for whatever reason, people want to always fill in this last step at the beginning too, because you always can fill in your first statement, your first reason, and your last statement, because your last statement is what we're trying to prove. We don't have a reason until we see how it went from step 3 to 4. That's going to be your reason for number 4. So how it moved from statement 3 to 4. All right, so they said that 3 and 7 are the same. So 3 and 7 are corresponding angles. Now we can assume that if lines are parallel, that corresponding angles are going to be congruent or have equal measures. That was the corresponding angles postulate that said that. That's why we have to have a postulate. This one is assumed to be true because we have to use that postulate in order to prove the rest of the theorems. So the corresponding angles postulates allows us to say that 3 and 7 are going to have equal measures, so those two angles are congruent. I also know that 5 and 7 have the same measure. So why would it that I can mark 5 the same as 7? Because these are vertical angles. And we know that if two angles are vertical angles, then they have equal measures because of the vertical angles theorem. So that's what allows me to say that 7 and 5 are the same. Okay. Now, if I look, 3 is the same as 7, and 7 is the same as 5, so 3 has to be the same as 5. That's going to be the transitive property of equality. You could also use substitution there. That would also work. It doesn't matter. So either of those would be a possibility there. Scrolling on down, it says, suppose the measure of angle 4 in the above figure. So using this figure, I'm going to use a different color now so we can kind of see what I'm labeling in it. Because showing your work is labeling on the diagrams. That's going to be a big thing this unit to find angle measures. You're going to have to label on the diagrams. You're going to want to highlight parallel lines often. And I do have patty paper. I know I mentioned it in the notes yesterday, but sometimes patty paper will help you kind of identify if there's a lot of lines so that you can highlight 2 lines in a transversal to kind of zone in on just those angles. So if you have at home parchment paper or wax paper or any kind of tracing paper, that will work great in order to go through these. Okay, so it says, suppose the measure of angle 4 is 57 degrees. So I am going to label 57 degrees for 4. In the above figure, describe 2 ways to determine the measure of angle 6. Okay, so 4 and 6. I could go right to 6 and say the measure of angle 6 equals 57 degrees because I have two lines and a transversal, so alternate interior angles are congruent. Okay, so I could that would be one route. That'd be your first option. There are lots of routes you can go with this. You could tell me that the measure of angle 4 equals the measure of angle 2 because of the vertical angles theorem. Right? 4 and 2 are going to be the same because of vertical angles. And then you could say 2 and 6 have to be the same because they are corresponding angles. And so that would be the corresponding angles postulate would tell us that. And then since 4 and 2 are the same and 2 and 6 are the same, then the measure of angle 4 equals 57 degrees, so the measure of angle 6 has to equal 57 degrees. That's the same as that, that's the same as that, we know. So you can just kind of explain your thinking here. So that would be your another option. There are more options here. You do not have to use those two. There are lots of different ways that you can explain this. Okay. Explain why angles 1, 3, 5, and 7 all have to be the same measure. Okay, so the measure of 1 and 3, I'll change colors again so you can see this. So 1, 3, 5, and 7. The measure of angle 1 has to equal the measure of angle 3 because of the vertical angles theorem. Okay, we also know that that's the same exact reason why the measure of angle 5 has to equal the measure of angle 7 because of the vertical angles theorem. Then you also know that 1 and 5 are corresponding angles and 3 and 7 are corresponding angles. So just state one of them. The measure of angle 1 equals the measure of angle 5 because of the corresponding angles postulate. So if 1 is the same as 3 and 1 is the same as 5 and 5 is the same as 7, they all have to be the same because 1 and 3, 1 and 5, so 3 and 5 are the same, and 5 is the same as 7, so 3 has to be the same. They all have to be the same. So just stating, you know, what's going on there, you can then say that, you know, the measure of angle 1 has to equal the measure of angle 3, which has to be the same as the measure of angle 5, which is the same as the measure of angle 7. So all of these are the same because 2 of them are the same, 2 of them are the same, and 2 of them are the same. And using substitution, you eventually get to all of them have to be the same. Okay. Is it possible for all 8 angles to have the same measure? Could 1 and 2 be the same even though they are a linear pair? What would they have to be if they were the same measure? And a linear pair we know has to add up to 180. Are there 2 angle measures that we know would be the exact same and add to 180? They would be 90 degrees, right? So if this was 90 and this was 90, then the vertical angle would be 90 and this vertical angle would be 90 and the corresponding angles down here, all of them would be 90. So yes, it is possible. They could all be 90 degrees, okay? Or right angles. You could say either one. They could all be 90 degrees or they could all be right angles. Either way, it's the exact same thing. So if one of them is 90 degrees, then they'd all be 90 degrees because of vertical angles, linear pairs, and corresponding angles postulate because we have 2 parallel lines and a transverse. All right, let's flip this over. And we have another proof here. The equal measure linear pair theorem. If 2 intersecting lines form a linear pair of angles with equal measures, then the lines are perpendicular. So we're going to try to prove this. So when we prove this, again, your given comes from the what it was told. So they're telling you if 2 intersecting lines form a linear pair with angles with equal measures. That's from the hypothesis. They're saying that 1 and 2 are equal measures. Okay. Now notice in here, they didn't line that up first, but the measure of angle 1 equals the measure of angle 2 is down here. So that's where your given is. You have to look sometimes for that given. Sometimes people don't use that until they necessarily need it. Okay. Now looking at this, you can see that 1 and 2 form a linear pair. If you see something, that is usually coming from the definition of a linear pair. It's coming from a definition if you can see it, because it's following the rules for what a linear pair is. The definition of a linear pair tells you these form a linear pair. If something's a linear pair, we know that it's supplementary. What says if two angles form a linear pair, then they are supplementary? That's the linear pair theorem, and I told you guys that you had to have that memorized for the Unit 2 test. That and the vertical angles theorem is something that comes back up over and over and over again. And these new theorems that we just learned, you will have to use these theorems for the rest of the school year. Okay, they will keep coming back up. Okay. What says that if 1 and 2 are supplementary, then 1 and 2 must add to 180? That's the definition of supplementary. Okay. Then they said the measure of angle 1 equals the measure of angle 2, which that we know was the given. So, what then says that 1 plus 1 has to equal 180? Well, if 1 plus 2 equals 180 and 1 is the same as 2, we can replace this 2 with a 1, and we have measure of angle 1 plus measure of angle 1 equals 180. That's substitution. Okay. So the measure of angle 1 plus the measure of angle 1 is twice the measure of angle 1. That is just simplifying, either combining like terms or simplifying. So simplify. Okay. You could also write combining like terms. I don't care. Okay. How do you go from twice the measure of angle 1 equals 180 to the measure of angle 1 equals 90? What did you do to both sides of this equation to get this? You divided by 2 on both sides. So that's the division property of equality. Okay. And then the measure of angle 1 equals 90 tells us that angle 1 is a right angle and L is perpendicular to M. That comes from the definition of a right angle and the definition of perpendicular. So the definition of right angle slash perpendicular, because both of those things, 90 is a right angle because the definition of a right angle, and then not, if it's a right angle, they are perpendicular because that's the definition of a perpendicular. So that actually uses 2 reasons, because there's actually 2 statements in that last sentence there. Write the converse of the equal measure linear pair theorem shown above. Is the converse true? Sorry. So to write the converse, if 2 intersecting lines are perpendicular, so that's how we're going to start it. We have to talk about, remember the subject stays at the beginning. So if 2 intersecting lines, and then we're going to say the conclusion first, are perpendicular, then the lines form a linear pair with equal measures. I'm sorry, linear pair of angles with equal measures. Missed a word there. That didn't really make sense. All right, so if 2 intersecting lines are perpendicular, then the lines form a linear pair of angles with equal measures. So if I draw in lines that are perpendicular, are the linear pairs always going to have angles with equal measures? If I draw in 2 intersecting lines here, and I know that they're perpendicular, do these linear pairs, or does this linear pair, or does this linear pair, do they have equal measures? Yes, this would be true, because all those angles have to be 90 degrees if you have perpendicular lines. Okay. Can we conclude in this diagram that P and Q are parallel? So this is the one where we're going to have to use the converses. We have to kind of discuss our way through this to figure out, can we say that P and Q are parallel? Remember, linear pairs and vertical angles do not need parallel lines, because a linear pair and a vertical angle are just made by 2 intersecting lines. We don't even know what's going on with this other one. So it has nothing to do with lines being parallel or not. So knowing that this is 71, the measure of angle 3 would also have to be 71 because those are vertical angles. And 1 and 2 would have to be whatever angle makes those supplementary, and they're the same because they're vertical angles. So 1 and 2 would both have to be 109 degrees. So let's look at, now that we have 1, 2, and 3 labeled, let's see what the bottom ones are, okay? So we're going to kind of talk our way through this. So if this is 71 degrees, then the measure of angle 1 would have to be 109 degrees. And this angle down here is also 109 degrees, which those are corresponding angles. So based on the corresponding angles converse, we could say that the lines are parallel. Okay? So you're given the 71 degrees. So measure of angle 1 has to equal 109 degrees, and we found that because of the linear pair theorem. Okay? Angle 1 and whatever angle this is, we could name it. Oh, hold on. Sorry about that. So since 1 and this angle down here are corresponding angles, we know that the lines have to be parallel. So we'll say that that's 5. So 1 is the same as 5. We can see that the measure of angle 1 equals the measure of angle 5, which then leads to P being parallel to Q because of the corresponding angles converse. Okay, so that would be one way. You could do this many different ways. You could say that 71 and 2 are a linear pair, so that's how we found 2 to be 109. And then 2 and the 109 that's labeled, those are alternate interior angles, right? They're on opposite sides of that transversal, and they're both interior to those two lines. So because of the alternate interior angles are congruent, we know the lines must be parallel. So either way, that's kind of going to be, you're just going to kind of write it in a couple sentences would be completely fine. That's what I'm going to, this would be something that I would expect you to do on an assignment right now, not a full-on proof. So those are just a couple of proofs that we wanted to do together and some explanations that we wanted to do together. If you have any questions, let me know.